In this video, we will learn about third law of motion. So it is a common experience that whenever an object A exerts some force on another object B, the object B also exerts some force on object A. Experimentally, it is observed that these two forces are equal in magnitude but opposite in direction. If we call the force exerted by object A on the object B as action force, so the force exerted by object B, okay, this is object A, this is object B. If the force applied by A to B is called action, so the force applied by B to A is called what? Reaction. So to make this concept clear, we will consider some examples. In the game of hockey or football, sometimes one player collides with the another player. Both players feel hurt, okay, because each player applied force to the other player. Hence, force applied by one player on the other is the action force. The force exerted by the second player on the first, it is the reaction force. Both the action and reaction force are acting simultaneously. Next is, when you strike a rubber ball against a hard wall or the floor, the ball exert a force on the wall or the floor. This is the action force. In return, the ball also exerting a equal force on the ball in the opposite direction. Due to this force of reaction, the ball rebounds back to you. Next is, so this is what the Newton's third law of motion. It states the difference, the relation between action and reaction force. So to every action, there is an equal and opposite reaction. In another word, the third law of motion states that when an object exerts a force on another object, the second object instantaneously exerts a force back on the first. And these two forces are always in equal in magnitude but opposite in direction. Next, the word action and reaction simply indicate two forces. If two objects interact, the force exerted by one object on the other may be called as action force, and the force exerted by other on first is called reaction force. Clear? What is action and reaction forces? Second is action and reaction both act simultaneously for exactly equal time. It is wrong to assume that action acts first and the reaction takes place later on. No, action and reaction both are simultaneous. Next is magnitude of action and reaction are always exactly equal, but their directions are mutually opposite. Next, the action and reaction force always acts on two different objects. Due to this reason, the action and reaction force never cancel each other. Okay, as you can see, if you are hitting a ball with the floor, so ball is exerting a force on ball, this floor, and force is exerted on ball. So this is basically there are two different objects, right? Next is from Newton's third law of motion, it is clear that force always occurs in pair. A single force in nature is not possible. So we will have some activity to demonstrate action and reaction forces. Take two cardboard, as you can see 60 centimeter, 60 and 18 millimeter thickness. Okay, first two pairs of hard ball bearing wheels, as you can say skates, okay, symmetrical on each wheel. In this manner you have prepared two small cards. Now ask two of your friends to stand on these cards as shown in this figure. Prepare a small bag full of sand and close it. Here, close it open with a thread. Give the bag to one of your friends and ask them to play a game of catch with the bag. When they play the game, observe their motion carefully. You are going to observe that when one player throws the sandbag to other, he receives an instantaneous reaction due to which he along with his card moves in backward direction. Means if he is like throwing this to this one, so he will move backward, right? So the same result is observed when the second player throws to the first. So this is what the action and reaction force. Next example, the experiment is you have to take two accurate springs, as you can see A and B. The hooks of two balances A and B are joined together. This is the hook. This is balanced. Okay. Now you have to attach the fixed end of balance B with a rigid support. Apply a force to the free end of spring balance A, as you can see here. Now you have to carefully note the reading of two balances. You will find that both the spring balances show the same reading on their respective scale. It is clearly shown that force exerted by a spring balance A and the spring balance B, it is equal but opposite in direction. Clear? So this is the experiment for action and reaction forces. I hope this topic is clear to you. Thank you.